let's get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so
we
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say
As the
developer,
Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am co-host Andrew Sullivan, joined as always by the lovely and amazing Mr. Jony Rickard. How are you, sir?
I'm good, dude. I'm good. Another happy Wednesday.
It is another beautiful mid-July Red Hat Wednesday. It is miserably hot outside. I don't know, I know people are here from all over the world and everything, but here in the East Coast, central part of the U.S. where you and I are at, it's nasty.
Yeah. Oh, it's like desert hot here in Texas. Yeah, it's it's pretty miserable and humid, unfortunately.
Yeah. Yep. Same here. So we are joined today by the one and only Bhavin Shah. Bhavin, you and I have known each other for, like 8 years.
Yep.
I mean, I've been at Red Hat for 5 years, and I knew you before that. So welcome. So Bhavin joins us from Portworx,
Yes.
and which is a part of the Pure portfolio. So today we're going to be talking about disaster recovery with OpenShift and Portworx. So Bhavin, if you wouldn't mind introducing yourself.
Yeah, thank you so much, Andrew and Jony, for having me on the stream, right? First of all, great job on the 104 episodes before this. I'm hoping that 105 is as good as the remaining. But as you said, Andrew, right? Like, I've been following you since my NetApp days. I joined as a new college grad in NetApp, and you were the virtualization TME. But on the Tech on Tap podcast, all of those things were great. And then just getting to know how you work and implementing some of those policies have been great.
Yeah, thank you. Yeah, I feel like it's funny because I forget how long I've been doing these types of things. Like the podcast, we started that in 2014.
Yeah, that's when I started at
2013, something like that. So yeah, we did that for a long time, and had a lot of fun with it. Back with Nick and Glenn and gosh, why am I completely forgetting? Justin, thank you.
Yeah.
Which I had lunch with Justin like 2 weeks ago. You'd think I'd remember his name, right? After having done this.
I won't tell Justin, Andrew. You're good.
It's okay. I will. I'm not afraid. Yeah. All right. Well, so Jony, how's it been? How you doing? I know this one, this particular episode took us a little bit to get coordinated and everything, but it's good. I'm really liking that we've got partners and stuff coming on now. We've had a number of folks come on, and this is just a continuation of that.
Yeah, no, it's exciting. And Bhavin, we reached out and had a discussion and stuff like that. And we were kind of talking about like what we want to talk about. And I came up with this topic today. I think that there's a lot going on. Bhavin's team and my team on the pattern side have been working together for a little while now and just got some stuff going. So it's cool how the whole ecosystem is starting to come together, right? Like the Red Hat stuff, the partner stuff, like it's all starting to come together, and we're making stuff happen, and I think it's a lot of fun. So I'm looking forward to today.
Yeah, it's almost like we know what we're doing or something.
Well, I mean, let's not get crazy.
Don't let appearances fool you. Let's be clear. I just realized I'm not looking at chat. Let's see, 5 Mike. Yeah, Winston-Salem. Yeah, it's miserable out there. I just saw my son, so it's summer for all the kids. He got up at the crack of 11 a.m. here on the East Coast. I reminded him that he's got to mow grass today, and he was not very happy with me about that comment. So we'll see how that goes. All right. So Jony, what have we got on the top of mind today? Actually, let me preface that by reminding folks why we're here. So this is one of the office hours series of live streams here on Red Hat Live Streaming. So what that means is that we are here to answer any and all questions that you happen to have about OpenShift. So whether it's regarding today's topic, whether it's whatever you have on your mind, whatever types of problems or questions you happen to have, Jony and I will do our best to answer them. We know a lot. We were just talking before the stream started that I'm a manager now. I've been a manager for like 18 months, so I know almost nothing anymore. Like I think I can spell OpenShift. So we know a lot, but we don't know everything. But we do have access to the people who know everything. So we're always happy to follow up, always happy to get those questions answered by reaching into product management or engineering or kind of wherever we happen to need to inside of both Red Hat as well as, like today, our partners. So don't hesitate to ask questions here in chat. Or if you are not listening to us live, I know a lot of people, watch after the streams happen live. Don't hesitate to reach out to us. So you can reach me at andrew.sullivan@redhat.com as soon as I find the thing here to show my name. Or you can reach me at Practical Andrew on all of the various social media platforms and all of that. Speaking of which, Jony, what's the new thing? Threads? Have you joined that thing yet?
I have not joined Threads. I've seen a lot about it. I'm kind of nervous to join any more social media platforms, but yeah, I've heard
Yeah.
I
about it.
did sign up though, Andrew. And I did link my Instagram account, and then I found out that for you to delete your Threads account, you have to delete your Instagram account too. So I'm like,
Oh.
was that a wise decision? But we'll see.
Yeah. Who was the thing that Google did that then they closed? Buzz.
Oh, yes.
You remember that? Google Buzz way back when? Yeah. And then didn't they I think they got in trouble for it or something. Anyways, because everything was linked together and somehow it shared information or something like that, and it
Not fun.
ran afoul of some law somewhere. Anyways. So yeah, email. We love email. Please don't hesitate to reach out via email. I know that I just recently responded. So apologies to anybody who is listening who was one of these folks. I just recently responded to like 3 emails that got buried in my inbox from way back during Summit. So yeah, like 6 weeks ago. So I'm really sorry to anybody who I missed emails from. But that is generally the best and fastest way to get a hold of us. And then the other person I'll throw under the bus here is Jony. You can reach Jony at JONNY at redhat.com or JRockTX1. And of course, I always like to throw out there, don't hesitate to reach out to us on Slack as well. So the Kubernetes Slack has a OpenShift users channel, which is a great place to reach out to not only Jony and I, but kind of a huge swath of other Red Hat folks that work on the OpenShift team, as well as the community at large. Right? It's a great way to interact with, talk with other people, get their experiences, learn from everyone. I'm forgetting something, aren't I?
There's also
Google
the
Plus.
There's also the OpenShift Commons Slack
Commons,
channel.
that's right.
Yep.
Thank you.
And
Yeah.
I put it up on the screen.
Yeah. So Commons is the official OpenShift community, and that's a great one. OpenShift Commons events happen kind of before KubeCons and Red Hat summits. I almost said OpenShift Summit. Man, that'll be the day.
Yeah.
Pretty soon, right?
Yeah, maybe we'll get there someday. So yeah, OpenShift Commons is another great one in order to participate into. But I feel like there's a lot more people on the Kubernetes Slack. Not to say that there's anything wrong with the Common Slack, and you can get answers to a lot of questions.
Yep.
So yeah, a new hype. Yep, Google Plus. I remember that one. That one. I think was one of the ones that it took them forever to actually allow you to close the account. They kept trying to link it into things and all this other stuff. Yeah.
Yeah.
And then somebody told me that Google Domains is shutting down.
Yeah. Yeah, they're selling. I don't know the whole story, but like they're essentially, and now I can't remember who they sold it to, but yeah, 28 million domains or something like that they sold to another provider. So
okay, well, I think I've got 1 or 2 over there. I guess I should go and check that out. But that'll be fun. More.
Yeah, I think I've got like 2 over there. Sorry, I didn't mean to cut you off.
No, you're good.
I was like,
no,
thoughts there.
So there's this whole thing, invisible labor, right? Or sometimes called emotional labor that happens. It's behind the scenes stuff that like at home, right? Somebody has to pay bills. Like nobody ever says, "Hey, thanks for paying the power bill," right? So it's kind of this invisible thing. And I feel like, doing something like managing domains is some of that invisible labor. Like you never think about, oh yeah, I got to go and, meddle with this or set this DNS or do these things, but it's kind of necessary and important.
Yep, exactly.
Anyways. So top of mind topics. What do we got going on today, Jony?
Yeah. So, the Red Hat Service Interconnect, which is really Scupper, officially went GA. So that's now, or Red Hat Service Interconnect, I think I said that right. So yeah, if you're looking at using Scupper, which is like a layer 7 networking utility resource, check it out. Scupper seems like it's an awesome project. It's been around for a long time, but now that it's officially supported at Red Hat, like it's it's definitely something to help you get like that app-to-app communication in multiple clusters, especially like when you talk about clusters at the edge or cloud versus bare metal. So it really helps kind of pull that whole hybrid cloud story together. And then there is a GitOps developer training that is on developers.redhat.com, and I'm going to see if I can actually copy this link and paste it here, maybe. But it's a nice little training that's online that you can take that'll give you some exposure to OpenShift GitOps. It'll give you some exposure to OpenShift pipelines and other tools. So go ahead and give it a shot, check it out, and yeah, hopefully it helps you out. And then the other thing that I have is, our schedule coming up is pretty action packed, right? I think that we've got some more partners coming on. So we've got Trilio coming on. We've got the OpenShift data science team. And then we also have the bare metal hosted control plane with the assisted installer team coming on. So a lot of good stuff coming up. Yeah, really excited, and it's going to be awesome. Also, I've been working with Hypershift a lot lately. So Andrew, I'd love to have a stream where we just like play around with Hypershift and actually go through it and actually deploy clusters and get crazy with it. So.
I'm all for it. I played around with Hypershift back in the early days. When it was dev preview before even tech preview. So yeah, I'm all for it. I'll also throw out a plug. So the developers.redhat.com stuff. So when you go there is a whole set of learning resources that you can use, that you can go and get started with OpenShift. So if you just want to get hands-on with any number of different things, let me see if I can share my screen here. This guy. So there's two things. So there's learn.openshift.com. And you'll notice that redirects over to developers.redhat.com/learn. If you scroll down through here, you get down to all of these interactive lessons. So I can sort by topic and search for example, OpenShift. And each one of these is a lesson. So I'm not logged into anything. And like I can click on this and it drops me right into an interactive session. So this is a huge, huge thing to me. I always love pointing it out to people. Like, I'm an administrator. I've been an administrator basically my whole adult life. But I want to learn more about how all of these other things work. This is a great way to get hands-on and, have a guided tour, so to speak. The other one I always suggest to folks is try.openshift.com. So if you want to, I'll say get more in-depth hands-on, like actually get access to, and now the redirect isn't going to work. Come on, internet. But that landing page will send you over to all the different ways that you can get access to OpenShift, including OpenShift is a part of the Red Hat developer series of entitlements. So, Noodle, we used to have a Discord channel and it was never used. Actually, we had a bot set up that would send all of the chat and links to everything over to Discord, and I think we might have had, aside from us as the hosts, we might have had like 2 or 4 people over there. So I can bring it up with some of the other folks and see if it's something that people would be interested in rekindling. But clearly, this redirect is not going to work. But yeah, it would definitely be something that I would be open to. Just unfortunately, fell through the cracks before.
So a new hype asked if the learning is free, because they're not saying that they're cheap, but that they're cheap. And yes, it is free. So you may need a developer account, but that's free. So you just register with your email address and you're good to go. But the training that we're sharing with you, like it's definitely free. Yeah.
There's also it's the DO080 course, which is like an introduction to Kubernetes and OpenShift course. Oh, hey, there, the redirect finally worked. So I'm sitting here running my mouth 5 minutes later. So yeah, the DO080 training course is also free, and it's a great one from an introduction standpoint. Jony, interested in hosting control plane, any security concerns? Is it multi-tenant, single control plane customer? Is that in the cloud? So without spoiling the surprise there and wanting to give the appropriate time and respect to Bhavin and the Portworx folks, I'll quickly answer your questions, Waleed. So security concerns, the big one to be aware of, if you will, is that so the way that hosted control planes works is it deploys the control plane services for one cluster as pods to a different cluster. So I have my primary cluster that's running here. I want to stand up a new cluster. Control plane pods get deployed over here. It deploys some virtual machines, physical machines, right, wherever that infrastructure is coming from. And then those nodes point to the pods, point to a service effectively, or a route that's running on that other cluster. So that cluster, the one that's hosting the control planes, it has the control plane services for probably many different clusters running inside of there. So that means that, if you're deploying it on-prem, you could have 5 or 10 or 50, however many clusters, all control plane services, all sharing the same set of physical or virtual servers hosting those. So whatever that means to you, some folks say, oh yeah, it's OpenShift, it's containers, it's SE Linux, right? I feel comfortable with that. Some folks, they want harder or more strict separation inside of there. So up to your security policies there. It is multi-tenant, so each one of those clusters is in its own namespace, or cluster control planes is in its own namespace in the hosting cluster. So I'm not sure what you mean by single control plane there. Customer, again, that security aspect kind of all depends on how you want to do it. I will note that you can do what I'm going to call a tiered approach. So, for example, I could have one hosted control plane cluster that uses a different cluster for each one of my tenants. So, for example, I have hosted control planes deployed to cluster alpha, and then I have a second cluster that is Jony, Bhavin, a third one for Bhavin, a fourth one for me, and I can deploy my own clusters and their control planes in each one of those. So you can provide separation in different ways. And then, is it in the cloud? Yes. So you can use ROSA. ROSA supports hosted control planes, and they have a huge set of documentation and other stuff that walks through all the trade-offs and stuff there, as well as we're working on a solution that should be published any moment now that talks about how to take advantage of that and some of the other architectural things that they do there. So, all right. So Waleed, we'll follow up with you on a number of these things, and I think you have convinced, not that Jony needed any convincing, you've convinced Jony to have a whole dedicated session on this.
Yeah, this, like, since we started talking about this, like, what, a year ago, it seems like, it's been something that I've been super interested in, and I'm finally getting around to kicking the tires on it, and dude, it is awesome. Like, just the speed of things and like the way that you can, it's really awesome. So yeah, Waleed, we'll do something. We'll try and do it right, and then maybe even get Adele to come help us out a little bit. We'll see. But yeah, I'm looking forward to it, Andrew. I'll book it now, so that way we don't have to worry about it.
Yeah. All right. So, Waleed, we'll keep track of your questions and stuff. We'll make sure that we address all of those and follow up with all of those. And I think we have your email addresses though, so we can follow up there too if needed. All right, let's talk about disaster recovery. So this is something, and Bhavin, I'll let you take over and go through your whole thing. But I think this is something that is really important and talked about in a lot of different ways. We've talked about disaster recovery a number of times here on the stream. We've talked about it from the perspective of how can I protect and recover an entire OpenShift cluster? How can I protect and recover just the workloads? And we've only sort of loosely touched on how do I protect and recover the persistent data. Okay. Usually our approach is more or less, go talk to your storage vendor, right? They'll take care of all of that. So I think taking, and I know, and I realize that in most cases, the application, the Kubernetes parts of the application and the persistent data are intrinsically tied together, right? You want to be able to recover not just the persistent volume, but the secrets and the config maps, and even all the way down to the container images that were used. So, I'll shut my mouth now and let you let you talk.
No, I think that's accurate, right, Andy? Andrew. First of all, we need a disaster recovery solution for Kubernetes. Like, I know we started with the whole ephemeral thing and stateless thing, but then stateful on Kubernetes has been around for a while. And then for larger enterprises, especially customers in the financial sector, right, they can't push anything to production until they have like a DR plan for their applications that they're running in production. So not just a DR plan, right, but also a zero RPO or recovery point objective. For people that are new to DR, recovery point objective is the amount of data loss that you can suffer. So ideally for your tier 0 and tier 1 applications, you want that to be 0. And then you have a recovery time objective, or RTO. That's the amount of time it takes for your applications to come back online on a secondary site. So the goal with disaster recovery is to have the lowest RPO and the lowest RTO, but also consider the cost parameter. Like obviously you can build the best synchronous DR solution, but do all of your applications actually need it, because there is a cost associated with it. So I think finding that right balance and making sure there is a solution that handles not just the applications but also the storage or the persistent volumes, as you said, Andrew, will definitely help. And that's what we are here to discuss, right? We are going to talk about how Portworx can help users or customers that are running on OpenShift build these synchronous, the 0 RPO or those asynchronous 15-minute RPO solutions, where you have a primary OpenShift cluster, you have a secondary OpenShift cluster, and you can fail applications over in case of a disaster event. So this can be, in case of a synchronous disaster recovery solution, you want your clusters to be in the same metro region. Again, this requirement hasn't changed, right? This is following laws of physics. Like you need a round trip latency of less than 10 milliseconds so that you actually are able to achieve that 0 RPO without your application suffering from a really high latency. And then for those cross-region, cross-cloud architectures where you might want to have a secondary cluster running in a different region, you want that asynchronous disaster recovery solution as well. So those are the two architectures that we'll talk about. I will demo one of those. I wasn't brave enough to do live demos today. I just wanted to have everything recorded, so I know nothing can go wrong, hopefully. I don't mess up recorded videos. But yeah, we have a bunch of slides for the people that are watching the stream right now or catch the recording later. And then we also have a few demos that talks about different Portworx features. So that's the plan of action. We can get started anytime you guys want.
Yeah, Johnny loves live demos. They always go great for him.
Oh my god, yeah. Like if you, yeah. I think I've had like one go right like the entire time. So yeah, it's
Yeah. Speaking of which, we briefly talked about this, Johnny. I think this is your 60th episode.
Is it?
Yeah.
Oh, it might be. Yeah. I'm getting old.
You're an old timer now. You've been here for well over half of the stream, so congratulations, or I'm sorry, I'm not sure which.
Oh, it's congratulations for sure. I love it.
Congratulations, Johnny, I guess. Yeah.
Thank you, Bhavin. Appreciate it.
Sorry, Bhavin, I'm going to pause for just a moment because rHope 9 brought up something that I think is super important, which is the RHSB 2023-001. I meant to mention this in the top of mind topics. So this is the one where there was I'm going to call it a misconfiguration in how the FIPS libraries were being utilized inside of RHEL and therefore CoreOS as well. So if you are a FIPS customer, please pay attention to what's going on there, all of the suggestions that they have on how to mitigate that and what to do as a result. But yeah, that's really all I'll bring up there. But that's a good one. Johnny, I don't know if you have anything else. I know you're still closely tied with some of those folks.
No, that's a good point. It's kind of crazy, but no, I don't have anything to add.
Okay. All right. Sorry, Bhavin, and appreciate your patience.
Yeah, all good. Okay, so Johnny, if you can share my screen, we can get started with the slides. So, okay. I know Andrew and Johnny already introduced me, but work for Portworx by Pure Storage. So Portworx used to be a startup that Pure Storage acquired, so it's now part of the Pure portfolio, but it still runs as its own business unit. You can follow Portworx, Pure Storage, myself, and then I also co-host a podcast around Kubernetes called Kubernetes Bytes using those social handles. So you can follow us on Twitter or LinkedIn. But then let's get started with just a 101 level of what Portworx is. So Portworx, again, this is not just me putting on a marketing slide, although this is a marketing slide, but the number one Kubernetes data platform that comes from analyst reports and talking to our customers. And again, this is not like the first year that we have been crowned number one Kubernetes data platform, right? This is like 3 years in the running, and soon it will be 4 years in the running. But Portworx, the entire portfolio of products that we have for Kubernetes and the Kubernetes data platform basically allows customers or users to run stateful applications on Kubernetes or on OpenShift in this case, right? So these OpenShift clusters can be running on-prem, in the public cloud, hybrid cloud scenarios, at the edge, As long as you have 3 nodes, you can run Portworx on top of it. We don't support single node OpenShift clusters today. But you can run OpenShift on bare metal nodes, and Portworx runs on top of your OpenShift cluster itself as pods. So we can consume the physical drives that you might have. So if you have hard drives, SSDs, NVMEs on your physical nodes or bare metal nodes, we can aggregate all of that into a unified storage pool and allow you to consume read-write once and read-write many persistent volumes from that unified storage tier. If you're running this on virtual machines, the same logic applies. If you have different VMDK files or different VMDKs connected to those worker nodes, we aggregate all of that into a storage pool. And again, the same features apply. And then if you're running things on the cloud, if you're using the ROSA service, right, we can spin up or automatically spin up those EBS volumes that you might need for storage, aggregate those into that same unified storage pool, and then allow you to deploy your stateful applications and consume storage. So we can run anywhere OpenShift can and run on top of OpenShift and provide you with features that we'll discuss in this stream. There are 3 different products in the portfolio. Portworx Enterprise being that software-defined or cloud-native storage tier that runs on OpenShift. We also have a data protection tool called Portworx Backup, which is something that we won't cover in this stream, but it's a Kubernetes native backup and recovery tool or backup and restore tool. And then we also have a database as a service, a database platform as a service, where we host the control plane for you, and you can connect your OpenShift clusters and deploy different databases and data services from a catalog of curated images that Portworx maintains. And basically, this platform allows you to run any kind of stateful applications on any OpenShift cluster. So with that, let me move on to.
Yeah, and I know, so my team of folks has done some work with PDS before. That's definitely something that I think, another one for the list, Jony, I think that one would be a really interesting one to highlight, is kind of the way that you all integrate database consistency, database persistent, both across the Kubernetes platform, OpenShift, as well as down through the storage. So we should definitely chat with you all about talking about bringing that on and talking more. If I could string coherent words together, I'll get there eventually.
I think when we were brainstorming ideas for this particular stream with Jony, we ended up deciding that there's so much to talk about. Maybe we do once a quarter or once in 6 months. Whenever you guys want to invite us, we're happy to jump on and talk about different parts when it comes to storage and OpenShift. Okay, so talking about what the stack actually looks like, right? So as we said in the previous slide, it fits on top of OpenShift and runs as pods. We have our own operator, which you can use to deploy. So for the first thing that you can do is find the Portworx Enterprise operator from the operator hub inside your OpenShift web console. Once you do that, you can deploy a custom resource called a storage cluster. Again, that custom resource takes care of deploying all the different Kubernetes objects that we need to provide you with the storage that you need. And then you can use this storage or all the capabilities that we'll discuss today for not just your pods that you have running on OpenShift, but also all the OpenShift virtualization VMs that you have running on top of OpenShift. So you can have just containers, just virtual machines, or you can have a mix where you're running both of those different kinds of workloads on the same OpenShift clusters. And Portworx Enterprise provides a consistent set of features to both of these application kinds. So that's just one gist. We'll talk about different features. So let's start by talking about what are some of the challenges that our customers are facing where Portworx can come in and help. The first one being just reducing the operational overhead and operational cost it takes to run stateful apps in Kubernetes, right? You don't want to configure, since this is a cloud native storage solution or a software defined storage solution, you don't want, it makes it easier for you to get up and running. So day 0 looks a lot easier. From a feature perspective, right? Like when Portworx wants to introduce new features, we are not dependent on a hardware being refreshed. Since it's all software based, you can upgrade to the next version of Portworx and get access to those new features. So it's completely software defined and can run anywhere OpenShift can. Since we provide this level of consistency, you can easily take your applications that are running, let's say on-prem, and you want to move it to a ROSA cluster, you can do that with Portworx as well. So for example, right, like it's not just enough to take the YAML files that you might have in a Git repository and deploy it again. You actually want the migration to include all your application data. So if you have an application that has been running for 6 months, you can't just copy the Kubernetes objects and say that you migrated your application. You also want all of your data to be moved as well. So that's something that Portworx can help you with. Talking about storage, encryption and role-based access control are definitely top of the mind for everybody. Portworx does provide encryption at rest, and as the DevOps admin or as the platform engineer who's architecting the solution, you can actually customize how things work. You can have different secrets for each namespace or each persistent volume. So even users that share the same multi-tenant OpenShift clusters don't have access to each other's persistent volumes if they wanted to. They are all encrypted with individual keys. Same with role-based access control, right? The administrator can control who has access to resources in a specific namespace, and we integrate well with Kubernetes RBAC objects as well. Talking about high availability, disaster recovery, data protection, that's the theme for today, right? Because Portworx is a software-defined layer, what we do is we provide you with in-cluster high availability and replication. So if you wanted HA for your persistent volumes, you can define that requirement in your storage class definition. So as an admin, you can decide, I want a replication factor of 3. So whenever a persistent volume gets dynamically provisioned using that storage class, it creates the primary copy, but it creates 2 additional replicas as well. So a total of 3 replicas that's running on your OpenShift cluster. And we have some things called volume placement strategies, which basically allow you to enforce affinity and anti-affinity rules. So if your primary node goes down, or if one of your worker node goes down, which is running your pod and is running your persistent volume, you don't have to worry about waiting for specific timeout so that the same volume can be mounted on a different worker node, and then OpenShift's pod is actually waiting for that persistent volume. Since a replica of that volume already exists on a different node, as soon as OpenShift reschedules the pod, your application can come back up and running. And again, this is all synchronous inside the same cluster. So it's high availability inside the same cluster. If you're running in the public cloud, right? If you are running across different availability zones, Portworx is smart enough to understand the topology keys for each of those availability zones and automatically distribute traffic without having to ask the administrator to do that. But if you wanted to implement the same thing on-prem, if you're running in a couple of racks and you wanted to make sure that you are distributing your workloads or your volume and your replicas across different racks in the same data center, you can do that as well using specific tags. The fifth thing is expanding your storage capacity on demand, rather than either having to pre-provision or over-provision resources, or having to wake up in the middle of the night and manually expanding your volume. So Portworx has a capability called Portworx Autopilot. It's a rule-based engine where you can specify in simple YAML files what specific actions to perform when a specific set of conditions are met. So it's basically a simple if this then that condition. So let's say if my persistent volume gets more than 70% full, please expand the capacity that it has by 50% or by 100%, so that I don't have to wake up in the middle of the night and take care of those expansions. Portworx is automating all of this for me. But as a fail-safe, right, you can, as an administrator, in the same YAML file, you can specify a max limit. Like, please don't expand it if it goes more than 10 terabytes. Obviously, you don't want any application to just take over your storage. You can set that maximum limit as well. And then finally, sorry, go ahead. Was it a question?
I just wanted to point out that this is stuff that has been in enterprise storage for a long time. Yeah. Right. It's just most of the time in most organizations, it's stuff that there's a storage team that is taking care of, those things behind the scenes or addressing those, configuring those things. So, we're starting to see this trend. I think this is a phenomenal example of hey, bringing enterprise storage features, exposing them directly to, not necessarily directly to the applications, but to the users of the platform, right? The Kubernetes users, the OpenShift users and admins. Giving them that capability of, I at least for me, I was a pure storage admin for a while. Hey, don't let this volume go offline, even if it doubles or triples or quadruples in size, right? The application, just let it do it, right? Type of thing. So yeah, seeing all of that type of stuff become available and then cleaning up the Kubernetes side of things after the fact is really cool.
And that's absolutely right. You don't want your applications to go offline because the PVC is full. And the secondary benefit of this is if you're running it on cloud, right? If you provision an EBS volume with 10 terabytes, you are paying for all of those 10 terabytes. Whereas if you start small and have these policies in place, you can expand as and when needed instead of having to pay for capacity that you're not using in the public cloud. So secondary benefit, but agreed. And then finally, I think the last thing before we get into more details was just the data protection tool, right? It's a separate tool that we won't discuss today, but Portworx Backup, it's available as a self-managed, something that you can deploy on your own on your OpenShift clusters, or you can consume a managed service where the control plane for the data protection tool is hosted by us, by Portworx, by Pure Storage. And then all you need to do is connect your clusters. We automatically show you all the different namespaces that you have, and then you can start creating backup jobs and store it in any S3 compatible, or recently we also added for NFS backup targets as well. So you can store your backup snapshots either in S3 buckets or in NFS shares based on the policies that you have, and you can fully customize how these backups are taken, including things like support for ransomware protection using object lock enabled buckets. So that's a quick highlight of how Portworx can help you solve challenges when it comes to storage. Not just one thing, but a breadth, hopefully a breadth of different topics. Next, if we talk about, let's see if you have any questions, Andrew. Like, do we usually stop for questions, or do you just want me to keep going?
So it varies. It depends on the questions that I and Jony have versus questions that come in from the audience, and and when we interject. So Selwyn does have a question here. Can PVCs be shrunk or?
Not really, right? Like once you are using that persistent volume, you can't really shrink it back because you occupied that storage. So that's not something that we can do today.
I'll ask a flavor of that, which is, can it be re-thinned so that you can, even if the PVC still has, it went from 50 gigabytes to 500 gigabytes on the storage side, can I, unmap and reclaim that space so that it goes back to being maybe just 50 gigabytes of consumed storage on the array?
Yes. So Portworx by default is thin provision, and we also have that auto FS trim capability where if you enable that flag, any unconsumed blocks will automatically be delivered back to the storage pool.
Okay, that's awesome. And I know, or I'm almost positive that OpenShift CoreOS does pass through things like unmap commands and all that to the connected block devices. So it should that should work as expected.
Gotcha.
And real quick, so there's a comment from Mr. Andy, and it was more like, understood that Portworx have work out with Cisco on a single bare metal server with full-fledged OCP. So I guess they're saying that they're aware of some work between Cisco and Portworx and OpenShift on a single node with Portworx storage.
Interesting. So like I know that the three companies have worked together and published a Cisco validated design, but I think since this is a storage product, right, we need 3 nodes for quorum. I'm not sure if like there was just single bare metal nodes, but like there were multiple OpenShift worker nodes running on top. But I can like look into it and maybe reply back, Mr. Andy.
Cool. Thank you.
Yeah. Okay. So talking about deployment architectures, since this runs on OpenShift or runs on top of Kubernetes itself, you can have a hyper-converged mode where each worker node in your cluster is actually a storage node as well. And this is the most common deployment scenario that we see. Like all nodes are contributing storage and hosting persistent volumes. But if you have applications that are more compute heavy and you don't need as much storage, you can also have a disaggregated architecture where only few nodes, let's say 3 nodes of your 10 node OpenShift cluster are actually storage nodes. And you can scale up or scale down your node group that is responsible for the compute part. And you can still have like the persistent layer inside your OpenShift cluster, but then you can add or remove nodes from a compute perspective as and when you need. So both of those architectures are supported. One of the things that I really like about Portworx, again, this was something that I liked before I started working for them, is the ability to completely customize the storage class parameters, right? Completely customize and create different tiers of storage for for different application teams that I might be serving. So for example, if I personally came from working with some VMware technologies, I know Andrew did as well. Having worked on vSAN and worked with storage policy-based management, this like made sense to me immediately. Like the ability to create custom storage classes with different parameters allows administrators to define how storage is provisioned for applications that are just test dev, or applications that are in production, or applications that need different snapshot schedules. All of this can be completely customized. So what I mean by different storage class parameters, right? When you define a specific Portworx storage class, you can define things like what's the replication factor, 1, 2, or 3, what's the file system type, XFS or ext4. Do you want to enforce any limits to the amount of IOPS or bandwidth that your persistent volume can consume, so you don't have a noisy neighbor issue, and you want to enforce this from a day zero perspective. Do you want to enforce any affinity or anti-affinity rule? You can do that using placement strategies. Do you want this specific storage class and all the volumes that are deployed through it be encrypted at rest? So you can do that using the secure flag. You can also set things like read write once or read write many persistent volumes or storage classes. And then you can also customize snapshot schedules. So, right, as an admin, I don't have to go back and look at all the different PVs that have been deployed on my OpenShift cluster and create a snapshot schedule. That's done at the storage class level. So whenever a volume gets dynamically provisioned, it inherits that snapshot schedule. The snapshots can be local, or they can be pushed out to an S3 repository that's outside the OpenShift cluster. And you can, again, as an admin, I'm just thinking about how easy can we make their lives, and defining things in a storage class definitely helps make it a bit easier, at least for me.
Yeah, and unfortunately, volumes still cannot move between storage classes. So
yeah, that's true.
I don't know if that'll ever happen, but that would be the equivalent of, hey, I provision this volume on, super mega ultra platinum storage, but it actually needs to be on, like the cardboard tier. Can I adjust or change where it's at and move stuff around? Which I can see, because of the abstraction of CSI, that would be hard. Right. If everything's on Portworx, or everything's on NetApp, or everything's on the same, Dell EMC array, you can probably go into the background and adjust those settings so that it reflects the new. But from an OpenShift, from a Kubernetes perspective, it has no idea. It could be saying, hey, move this volume from, local storage to Portworx, right? And it wouldn't know the difference.
Yeah.
Manoj asked a question here. So the same way Dell Isilon file storage also works, I'm assuming where Isilon driver pods spin up as pods in the same cluster, is Portworx the same?
Okay, so the way Dell Isilon works with the pod that's running in the same cluster is they deploy a CSI plugin. So basically, your storage is actually being provisioned on the backend Isilon array, and all you have is a connector or a CSI plugin that's running on your OpenShift cluster. So all the provisioning operations are fed through that CSI connector. For us, all of the entire storage layer is sitting on the OpenShift cluster itself. So what we do is, let's say you are running on a 3-node bare metal cluster with 8 NVMe drives. So you basically have a 24 NVMe drive storage pool, and then that storage pool is used to provision these virtual volumes or Portworx volumes. So you can have a terabyte of these drives, so you have 24 terabytes of storage pool capacity. But then if you just need a 5 gig persistent volume, that becomes a chunk of that overall storage pool. So it's not going back and asking for a new LUN from a backend storage array. It's just provisioning it inside the virtual storage pool. Hopefully that helps.
So, Bhavin, does Portworx support object storage as well? Like, I know we're talking a lot about block and stuff like that, but like, does it support object store?
So right now we are waiting for the COSI standard to be GA. Right now it's in beta. So we do have an implementation where what we can do is if you want to use Kubernetes objects to provision your object storage buckets instead of having to use S3 APIs or let's say pure FlashBlade APIs, you can use Kubernetes objects like bucket class and bucket claims and bucket access, similar to storage class and persistent volume claims, and provision these buckets. But it's not on the storage pool. It will be outside on the backend system. So if you're running on AWS, it will actually deploy an S3 bucket and give you access to it for your Kubernetes applications that are running inside your OpenShift cluster.
Okay, got it. Thank you.
Yeah, but once the COSI standard evolves and has a good standing, I think right now we are completely compatible, but in the future as well, like we want to make sure that we are right there with them.
Yeah, that's awesome.
Okay, moving on. Cloud drives, right? We hinted at some of this. This is where you can use automation. So like if you're deploying things on AWS or AKS or GKE or even pure FlashBlade, right? Or Flash Array, you don't want to manually provision those EBS volumes. I'm just going to use AWS as the example. It comes easy to me. You don't have to manually provision EBS volumes and mount it at the same path on your OpenShift worker nodes. All you have to do is just go to the Portworx spec generator on central.portworx.com. You tell it like, okay, I need 2 terabytes of storage with a GP3 volume attached to each node, and that's it. when you deploy or apply that YAML file against your OpenShift cluster, we talk to the AWS APIs, provision those back in EBS volumes, mount it to at the same location on your OpenShift worker nodes, and aggregate them into a storage pool. So Cloud Drives is just making sure that there are there's no space for human errors in terms of provisioning volumes and mounting them at the same locations. All of that is automated under the covers for you. Talking about volume placement strategies, again, this is where we can enforce those affinity and anti-affinity rules. Examples include things like, let's say you want your volumes and its replicas to be spread across different worker nodes, which makes sense, right? You don't want your volume and your replicas on the same node. So if that node goes down, you are down offline. You want your replicas to be spread across. That's by default. But if let's say you are running a stateful set object, and maybe MongoDB data and log volumes, you want them to co-locate on the same node, at least their primary volumes, you can enforce that as an affinity rule as well. If you're running multiple of these across different namespaces, and you want the same rule to be applied from an affinity or anti-affinity perspective, you can also take into account labels that you use at the namespace level and enforce those policies. So just VPS gives you the flexibility to include things or include these rules and figure out how volumes are being provisioned. One of the advantages, like there is an open source project called Storage Orchestrator for Kubernetes, or Stork, which is something that Portworx uses. So Stork is kind of an addition to the way Kubernetes API server and Kube scheduler works, where whenever a user, let's say, deploys a YAML file, a pod spec, which has a persistent volume with it, Portworx will deploy the persistent volume on a specific node, and then it will work with the Kubernetes scheduler to make sure that the pod is co-located on the same node to ensure data locality. So you don't want your pod to go over the network to access storage, right? All of those are co-located. So again, that's something that's delivered by default using that open source project called Stork. We covered kind of the automated storage capacity management, the challenges there are. I just wanted to show an example rule. So this is, again, everything that you can do in Portworx we are YAML first. We are catching up on the UI front right now by building things like the dynamic plugin for OpenShift Web Console. But an autopilot rule allows you to expand your persistent volumes. It also allows you to expand your actual storage pool itself. So if you're running in a cloud environment and you want more capacity, you can have an autopilot rule where if my volumes are getting filled up and they are expanding and my pool is running out of capacity, you can have an autopilot rule that expands the storage pool as well. So basically you specify a spec. So you specify the labels that it should match, like specific namespaces for specific applications. You can have that. And then condition is where you specify how much storage, what's the threshold that once it's exceeded, you perform a specific action for the user. So we have a demo for it if you have time today after the DR demo. But yeah, that's how autopilot rules can be specified. And then finally, I think if we talk about disaster recovery, there are two different modes as we spoke about. Asynchronous DR, where it is two different OpenShift clusters, your primary and your secondary OpenShift cluster, with two different Portworx storage clusters running on those OpenShift clusters. And then what we are doing is we are establishing a DR relationship between the two. So we're creating something called as a cluster pair object, which basically maps the two clusters together or links the two clusters together, so that whenever a failure or a disaster event happens and you have to fail over objects, you can take applications that are running on your primary site and bring it online on the secondary site. The way this works, again, we look at this in a demo, but once you have, let's say, an asynchronous DR solution, right? You have your primary cluster, applications are running there, and the instance the first migration happens, Portworx will spin up all the necessary resources except the actual pods or except the actual OpenShift VMs on the secondary cluster. So you will have the deployment object already created with the replica count set to 0. You will have the service object, the persistent volume, config map, secrets. Everything is ready to go. The only thing that you'll see is missing are the actual application pods and virtual machine objects. And in case of a disaster, when you want to recover the application, all you have to do is log into the secondary site, execute one simple command called activate migrations for that individual namespace. And since we already had the metadata of how many pods or how many replicas that deployment object had, we'll spin up those number of pods and your application can be back online. So this is how we deliver like really low RTO recovery time objective, because it's basically the time OpenShift or Kubernetes takes to spin up those pods and spin up those virtual machine or power on those virtual machine objects. So this is how async DR works. So two different OpenShift clusters, two different Portworx clusters. when we're talking about that synchronous disaster recovery solution, right? This is where you have your primary and secondary OpenShift clusters, but you have a stretched Portworx enterprise storage cluster. So what does this mean? Like whenever my application that's running on the primary side is writing any data to the PVC object, it automatically copies everything. Like this, the replication is handled at the storage layer. So even before the write is acknowledged on the primary side, the data is already present on the secondary side. And the same logic applies for the OpenShift or Kubernetes objects. So everything will exist except the pods and VM objects. But as soon as you want to do a failover object and you run that command, we'll bring those pods online and bring your application back online. Both of these deployment scenarios can work are active passive, right? Like a single application can't be active in two sites. It will always be running on your primary side. But if you wanted to use your capacity in a better way, you can actually have certain applications that are running on the secondary side, and you use the original primary side as the failover side for a different set of applications. So it's active, passive, primary, secondary, and the failover happens in a matter of seconds to minutes instead of I think this is just my personal opinion, right? This is better than just having backups available. So in case of a disaster event, you don't have to worry about spinning up new OpenShift clusters or any Kubernetes distribution cluster. Find the right backup snapshot to restore from, and then perform that restore operation. Because I personally haven't been in rooms when a disaster has struck, but I can only imagine that there is a lot of panic. And in that scenario, you don't want to worry about finding the right configurations for your OpenShift clusters and then bringing your applications back online. You want this to be as seamless, as foolproof, as easily tested as possible. So in case of a disaster, log into your secondary cluster, execute one command per application, and that's it, you're done. You don't want to find the right backups to restore from.
There's usually not a lot of panic because you kick those people out of the room when disaster happens. They're just getting in the way. They're not being helpful. That you always avoid the status calls, right? Because every person in the entire chain of management wants to get on a phone call and get constant status updates. So
Yeah.
no, so I have a whole bunch of questions, but I think a number of them will get answered by looking at the demo. So like things like, how do we orchestrate, that failover recovery process? How do we configure all of these things? Is it done in a Kubernetes native, programmatic way, or is there something else that has to go in there? So I think you'll answer most of those through the demo.
Yeah, let's get started, right? And then if you have questions, like, please feel free to stop me. So there are 3 different objects that we need to be deployed. We need deployed on your OpenShift clusters in this DR topology. The very first step being cluster pair objects. Again, this is assuming you already have Portworx running, but a cluster pair is just a trust relationship between the primary and secondary clusters. So it basically syncs the storage layers and connects the Kubernetes clusters. And then once you have your cluster pair object, again defined through a YAML file as a Kubernetes native object, the next step is to create different schedule policies. So let's say I have 10 different namespaces that needs to be protected. I just need one cluster pair object that connects my primary and secondary together. But then I can have different schedule policies for different SLA settings, right? So some of my applications might, even if it's a sync DR solution that's just handling storage, I still need to copy the Kubernetes objects at regular intervals. This is where a schedule policy comes into the picture. Or if I'm doing that asynchronous relationship, minimum we can do 15 minutes, but then you might have tier 3 applications that are okay with like a 1 hour or 2 hour RPO as well. You can customize all of those things using a schedule policy custom resource that's again running on your OpenShift cluster. And then finally, the way to bring everything together, like an SRM recovery plan, is to define a migration schedule object. So a migration schedule basically brings all of these resources together. So it tells Portworx, it tells OpenShift, like, what's the namespace that I want to deploy this migration schedule in, and what's the namespace that I'm migrating right now. So you can have one cluster per object, but you can have individual migration schedules for different applications if they have different, if they are running on different namespaces. You can. This is the place where you specify things like what's the cluster pair, which is the cluster pair object that I want to use. Include resources is true, because again, we're not just worrying or helping you protect your data, but also all the different Kubernetes objects or OpenShift objects. start applications flag is set to false because, again, at the first migration, you don't want to bring your applications back online on the secondary side. You want this to continuously happen and your application being running on the actively on the primary side. Include volumes can be false or can be true. So what this means is, if you're running a synchronous DR solution where you have that stretched Portworx cluster, include volumes is set to false inside migration schedule because the replication is handled at the storage layer. But if you're running in an async topology, include volumes will be set to true because as part of each migration, I want to make sure that the incremental changes that have been made to my persistent volumes are copied from a primary to the secondary side. And then finally, I can associate a schedule policy that I want for this specific application. So everything that's running in Kubernetes runs in a namespace. I can create a migration schedule per namespace and protect my applications. Hopefully this answers some of your questions, Andrew, and we'll look at more on how these things are actually done in a demo.
Yeah. So we do have a couple of questions.
Okay.
So from Babuni, does Portworx require additional license, or is it included with an OpenShift subscription?
So it is an additional license. We love to partner with Red Hat, but right now you have to buy Portworx separately. I'm sure if you're working with a channel partner, they can sell you Portworx licenses with DR capabilities.
Is Portworx available through the marketplace? Do you know?
It's on the Operator Hub marketplace. I'm not sure. That's something I'd have to check.
Okay. Yeah, I'm not sure either. And then apologies for mispronouncing names or usernames. Blajo. How are volumes rebalanced after failback and asynchronous setup?
Gotcha. So similar to how you can have a cluster pair object and a migration schedule going from primary to secondary, you can have the same things already created on the reverse side as well. So let's say you want to do a failover operation because your primary side is down. You bring your applications back online on the secondary side. Everything is looking good. But a day later, your primary side is actually back online and you want to fail back your applications. You can just activate migrations in the reverse direction. And you can bring all your applications back online on the primary the way they are supposed to. I see a question. Do we have to install Portworx on 2 different OpenShift cluster for Portworx stretched storage cluster? So yes, you'll have to generate configuration files from our spec generator, central.portworx.com, and then apply those same YAML files with the same cluster name, just a different cluster domain name, and apply those on your 2 OpenShift clusters.
Yeah, so it's 2 separate OpenShift clusters with Portworx services deployed to each, creating one logical Portworx cluster.
Yep. And then in a synchronous DR solution, we obviously need a witness node. So that's sitting outside the OpenShift cluster. It can be running as a container on a third site if you want. And that can help you with the split brain or network partition scenarios and make sure that you don't run out of quorum.
Awesome. Thank you.
Yep, and Bhavin, I just checked the marketplace. The Portworx, it's not in there. So that's just the easy access button to do the subscription stuff. So definitely in the Operator Hub, but not in the marketplace yet.
Yeah.
Oh, go ahead.
Just for anyone who is curious about what the difference there is. So marketplace is where you can go in and I think billing is done through a single interface, single place. That's my understanding of the advantage there.
Yep.
Whereas with Operator Hub, so you get all of the advantages of it being an operator, right? You click in Operator Hub, click install, you create an instance of the CRD, and you're off and running. But for those instances, you would be responsible for whatever entitlements, subscriptions, right, et cetera, either by connecting with your partner or with the vendor themselves directly.
But that's a good question and good suggestion for me to take back to the Portworx team. Maybe we get listed on the marketplace sooner.
Yeah, I have no idea what that looks like or how that works or anything like that. So let's see. In a stretch cluster, how does synchronization work? Is it directional or bidirectional?
So it will depend on the migration schedule. So if you have applications running on the primary side, it will be unidirectional. But then on the failback, you can make it go the other way. If you have applications, like if you're running different set of applications on the secondary cluster, you can go the other way as well. I know that's confusing with the diagrams, but yeah, it is unidirectional when it's one application in question.
Yep. Yeah, and for so Blajo question to Red Hat: will there be DR possibility in the future with ODF? I don't remember the ODF capabilities off the top of my head. I want to say that there are plans for, if not available already, there are plans for both synchronous and asynchronous replication inside of there. But I can spell ODF, and that's about my extent of knowledge on it. So
Yeah, without I don't know the specifics either, but yeah, I think you're right. I think there's a capability there. I just don't know like the details on it.
yeah, we'll have to ping over to the IBM folks and ask them.
Yep, I'll take note of that.
Is there a plan for Portworx to be pay as you go? As either it's currently it's either per node yearly or hourly yearly, if I'm not mistaken.
No, there is a pay as you go option. So you just pay for the amount, amount of time you're running specific nodes. So there are options that we can do.
And is it capacity that it's no? Okay.
Just the worker node where it's running on. So it's a per node license.
Got it. Okay. So yeah, so it doesn't matter if you have 1 terabyte or 100 terabytes.
Yeah, go nuts, right?
Nice. Let's see, Peter, does this DR capability work with virtual machines? So, which I'm assuming means OpenShift virtualization.
Yeah. And the answer is yes. Like the demo that we have is actually going to show a mixed app where your front end components are running as pods and your backend MongoDB database is running on VMs. And Portworx can back up everything as long as it's running in the same namespace. We can protect everything and have a DR strategy for it.
Awesome. Well, I'll quit asking questions. The audience, please continue to ask questions. I'll stop asking questions so we can see the demo.
Well, these are some good questions. Thank you for asking. Okay, so this is a simple demo application that we use inside Portworx, inside the tech marketing team. I don't know if you know Eric Shanks from the VMware ecosystem, the IT Hollow. He's one of my teammates. He builds this application as a fun way to showcase some of the capabilities that Portworx provides. So it's a simple app where you can create a new user and start just placing some random orders for barbecue that you want. And all of that information is stored in the backend MongoDB database or MongoDB collection. So what we are going to do in this demo is just log in, place a simple few orders, look at the database, look at how the application is actually built, and then create a DR plan for it. So a few options to choose from. I couldn't decide whether like I should go the pulled pork route for Andrew because North Carolina or go the brisket route. So I just played it safe, have a smoked chicken recipe, and then selected a few sides for, I guess, the stream. Once the order has been placed, you can look at the order history. So you have different options. Me being vegetarian, I did select cauliflower steaks and portobello mushrooms to go with. But yeah, these are nothing but entries stored in the backend database. If we log into our primary OpenShift cluster, we are deploying things in the app-demo namespace. So you will see we have a few front-end pods that are running the UI for that Portworx barbecue application. And service objects, again, that you can use to access the app. But we also have a virtual machine object that's running on OCP as that OpenShift virtualization VM. And that's our Mongo VM that's actually running the MongoDB database. So what we can do here is take this application and then protect it, right? But before we do that, let's look at the persistent volumes. And then we exec into the MongoDB VM and then look at the different entries in our database collection as well. So as you can see, our MongoDB VM is backed by a PVC where all those entries are actually stored. It's being provisioned, or it's being dynamically provisioned using a Portworx storage class. Now, if I just log into my virtual machine using a simple SSH command and then go to that specific MongoDB collection, I can authenticate with a demo user that we have, a super secure password, right? Like Portworx. And then the username, we can see the same orders that we saw through the UI in the order history being actually committed into the MongoDB collection as well. And then there are two different collections. One is where we store the user information. The orders collection is where we store the actual order. So you'll see all the different orders that we saw ordered through the user demo at portworx.com. So we have some data to play around with. Now let's go ahead and try like build that DR solution. So what I've done in this demo already which I shouldn't have, as I was answering questions on the stream. I have already created the cluster pair object between the primary and secondary cluster. But let me pause here for a second, right? So cluster pair is an interesting resource. So the way to create this specification is you log into your destination cluster, run a simple command called generate cluster pair object, and dump all of that information into a YAML file. So you generate the config on the destination cluster, but then when it comes time to actually apply the cluster pair config, you apply it on the primary side. So this is how your primary side knows all the different service endpoints that it needs to talk to on the destination side or on the secondary cluster. So we have a cluster pair object already set up. The storage status is showing not provided because this is a synchronous DR solution. Replication is handled at the storage level, and the scheduler status is ready, which means that if I want to fail over my objects from my primary OpenShift cluster to my secondary OpenShift cluster, I can do that. It's looking good for me. If you are doing an asynchronous relationship, the storage status will also show ready and not show not provided because the replication is handled at those regular intervals. Another migration schedule object. So here, instead of just using the demo namespace we're using that we saw in the slides, we're using an app-demo namespace. We are associating the demo-policy. Again, by default, there are a few schedule policies that are automatically created for you when you deploy Portworx. But if you wanted to create new schedule policy objects, you can do that as well using simple YAML files. And we have examples on our documentation site as well. And then the same flags that we saw, except one, like auto suspend, I've commented that out, but that's basically helpful in scenarios where, let's say, your primary site went offline. We will automatically suspend any further migrations or not even attempt it, right? So you can just log into your secondary cluster and activate those migrations. So that's how the auto suspend flag works. I'll show you, like in case where you actually wanted to simulate a disaster event, the steps that you need to take in this demo. But let's go to our secondary site. Again, similar OpenShift cluster. I think it's running 4 worker nodes, 3 control plane nodes or master nodes. That's our secondary site. If you look at the app-demo namespace, this is even before we have done anything, right? Even before we have initiated our first migration. You won't see any resources being available, no persistent volumes being created here. So this is a fresh OpenShift cluster with just the namespace being created. As soon as we apply the migration schedule object, so the migration schedule object basically creates a migration object at the schedule policy interval. So as soon as you apply it, it will create the first one. But then let's say you have a schedule policy of 15 minutes. That's the next time it will create a second migration object. So something like a cron job and a job object, like that's the relationship between a migration schedule and migration as well. So once I apply that YAML file, it will start the first migration. Again, storage will be handled at the storage layer, but all the different OpenShift objects in the app-demo namespace, including OpenShift routes, secrets, config maps, the pods that I might have, will start migrating over to the secondary site. So if we look at the migration schedule, we see that it is already successful. So it shows you the stage. So if I actually caught it on time and if I had a lot of data, I can actually see how many objects are already done, how many are in progress. If it's an asynchronous relationship, it will also show me that, okay, X% of my volume has already been moved over, but I'm still in between migrating all of my data inside my persistent volumes. So as you can see, we didn't migrate any volumes as part of the migration schedule because handled at the storage layer, but we migrated 10 different Kubernetes or OpenShift resources as part of the migration. So once that's done, what we can do is navigate to the secondary site and see what things look like in a normal scenario when a DR solution exists, but there is no disaster event. So what things look like in a non-DR, a non-disaster scenario. So we'll run the same commands, do a get all in the app-demo namespace. And here you can see we already have the service objects, the deployment objects with their replica count set to 0, the virtual machine object, which is in a stopped state, the route object already created, you see the persistent volume existing on this side as well. But again, it's not connected to any pod. It's not attached to any pod. So it's ready to go if you wanted to. But right now, your application is just waiting there to be spun up if a disaster strikes. So now let's go ahead and simulate a disaster. So again, if in case of an actual disaster, you would like lose access to your primary cluster. So none of these steps are actually needed, but this is just how, if you wanted to test out your DR solution every 6 months and make sure that what you have works and your applications can come back online on the secondary side, you can go ahead and deactivate a cluster domain. So when you're deploying sync DR, as we know at this point, right, it's a single stretch Portworx cluster, but each the nodes that are running on a specific primary OpenShift cluster and a secondary OpenShift cluster are their own cluster domains. So a cluster domain is mapping to a specific OpenShift cluster. So everything was in sync, but now since we deactivated things, the primary cluster will go out of sync, and only my witness and secondary cluster will be in sync. So we know that the quorum has lost on, like the nodes have been lost on the primary side. My secondary side is the one that's actually running right now. Again, this is trying to simulate things, right? So we'll scale down our application on the primary side, and then we'll actually log into the OpenShift web console and turn off the VM on the primary side as well. And then once we have done all of that, we can start bringing our applications back online on the second side. So we'll go to the web console, find our Mongo virtual machine, and then just power it off. Let me fast forward this a bit. Okay, so now we are logged into the secondary side. It's time to perform that recovery or restore operation. And it's as easy as running one simple command. So you can, if you wanted to control the order in which your applications are brought online, you can do a startctl activate migration, and you can specify the namespace where your application is running. So activate migrations app-demo. But if you wanted to bring, let's say, 5 applications online at the same time, you can, if you wanted to bring all your applications online at the same time, you can do a startctl activate migration, all namespaces as well, and Portworx will bring all your applications back up. As you can see, our pods have now started deploying and are now in the running state. Our virtual machine is now in running state. So things that had stopped without a user intervention with just one single command, things are now starting to spin back up. This is something that obviously you can automate, which I didn't for this demo, is actually editing the route object so that your load balancer, if you're doing a DR solution in a production setup, you might ideally have a load balancer setting which has a health check for a primary side and secondary side and will automate all of this. But again, for demo purposes, I'm just pointing, using a new route to access the same application that we had. So at this point, sorry, go ahead, Andrew.
I was just going to mention the same thing of bringing the application back on the OpenShift cluster doesn't necessarily bring clients, right? Whatever the application workload was back over to the new cluster. So make sure you take that into account.
Yep. Thank you. So once everything is up and running, we can actually take that host/port combination of our route object and then verify that all the orders that we had placed earlier using Portworx Barbecue are now running or the user can access that same application, and all the orders made their way to the secondary site as well. I can continue using my application, place more orders, and then when my primary site is back online, I can perform a reverse migration or a fail back operation, and then move my app back to the primary site. So this is how we can do DR when it comes to OpenShift. Both containers and virtual machines. And then this is a sync DR scenario. We can similarly do an async DR, wherein the only change you'll need is inside the migration schedule object, you have include volumes flag set to true, and we can do an async DR.
Awesome. Yeah, that definitely helped of showing the process, showing the CRs that are involved, and helping to describe all of those things. So thank you. So there is a few questions that have come in, trying to keep me honest here. Babuni, so we need to understand Portworx. We need 2 clusters, one active cluster where the applications are running and one backup cluster for synchronization between the two, which I think that's not just a Portworx thing. That's going to be, and that was my response, which is anytime you have, a Kubernetes native storage offering, you're going to need, 2 clusters to do any kind of replication. The same is true with even a traditional enterprise storage array. If you're doing synchronous replication between them, you got to have 2. Sometimes you can work around it by, I say work around it. It's one cluster that's accessible from both locations, but you still have a single point of failure there, so it kind of defeats the purpose. But, and then somebody down below, Blajo, pointed out that you also need a witness for the replication piece.
Yes, so witness is just to there to act as a tiebreaker. So it doesn't actually get involved in the data path, doesn't do anything. It's just there to make sure that your Portworx storage cluster doesn't lose quorum in this stretch
Yep.
topology.
Yep. Yeah, you don't want a split pane scenario where it doesn't know which one is which and what data has or hasn't been committed.
Yep.
Let's see, Babuni. If yes, that means we have to pay 2 cluster license costs as well as the Portworx license cost. So yes, I don't think Portworx is considered an infrastructure workload. I'm not positive on that. Okay, it's not. So yes, however, you can have 2 active clusters that are replicating to each other, right? So I could have, if my applications, my workloads, whatever, they're both doing something, and I have the Portworx portion cross-replicating, I can bring those applications back up. Maybe an example is, you have a cluster that is production and has all of the resources, everything you need for production associated with it, and then you have one that's for test or dev or CI or whatever, and that's your replication target. So that way you still have those things there. You're still utilizing both clusters for their intended purpose, but should disaster strike, which we hope it never does, you would have everything there.
And again, this is only relevant for your tier 0, tier 1, or whatever applications that need this 0 RPO or 15-minute RPO. You can always go back to the data protection tool that we have. If you want 8 hours of RPO, you can just have a backup stored somewhere and then eventually restore from that backup snapshot. So it depends on the SLAs that you have for different applications that you're running.
Yeah. Yeah, in our Hope 9, we did get out a new update to the subscription guide. I don't remember. It's been so long that one has been in the works that I don't remember what's actually changed. I feel like we need a change log now for these things. And just in case anyone's curious, and let me dig up the link. Man, I cannot talk and type, and I got to remind myself of that every time I try. So we'll post
it's like
that
walking
in
and drinking water. Some people can't do that. I don't know why.
Yeah. So the link I just posted in there is the self-managed subscription guide. So the goal there being to provide clarification around different use case scenarios and how licenses or entitlements, I should say, are applied to OpenShift clusters when they're needed, when they're not. So that's where the whole concept of like an infrastructure node comes from and all that other stuff. Containers and VMs living together. Yes, very much so. Thank you, Peter. And not only that, taking advantage of the SDN for the container-based application components to talk to the VM-based application components, which is really awesome. I always like to, and I know we've talked about OpenShift before here on the stream. It's many of the benefits of containerization and Kubernetes without doing the containerization piece. Can we designate both sites as primary? Let's assume there are a few apps running in site A and a few in site B. When site A goes down, does the data get available instantly in site B and vice versa? That's Shirajan. Apologies for butchering names. I'll kick that one over to you, Bhavin, but I'm pretty sure the answer is yes.
Yes, it is. As we saw in the demo, right? Like sync DR, 0 RPO, everything is there. Even in an asynchronous DR solution, you still have the same persistent volume, but it will have a gap of maximum 15 minutes, let's say, if you have a 15-minute RPO.
And yes, Jony, I do love Git. Git and I, we get along like cats and dogs. So I'm one of those people who I don't know. I've been using Git for I don't know how many years, and if it goes beyond the basic, kind of the basics, I always have to look it up.
Yeah,
I every single time. I should have a cheat sheet. Christian tried to share with me a cheat sheet one time. I'm not sure what you mean or what you mentioned for etcd is there, Blajo. You might need to clarify there.
Like one of the things like I can talk about is when you have so if you're deploying Portworx on a single OpenShift cluster, not doing synchronous DR, just running it without any DR solution, or if you're doing async DR, etcd can run inside the OpenShift cluster itself. But in a synchronous DR solution, you need an external etcd as that key value database where Portworx stores metadata information.
Got it. Okay. 0 RTO and RPO is like unicorns. It is definitely difficult for the RPO, or excuse me, the RTO in particular.
Yeah.
RPO, maybe this is because I have a storage background. RPO feels a little easier because, it's relatively, it's not uncommon for storage vendors to have a synchronous replication option. But RTO means that the application as a whole has to be able to accommodate that. So, how do I take everything from the load balancer that the clients connect into and orchestrate everything behind that so that it's a seamless failover for all of those clients and everything that's happening? It's far more complicated than just, I'm not going to say it's simple, but just replicating the storage in a timely and efficient manner. All you need to do is ask. Oh yeah, get SCM. Yeah. Thank you, rhope9. Yeah, someday I'll learn. My current manager title is not a good omen for that, however. So, let's see. Babuni, could you please mention how we can take all namespaces backed up to a single migration schedule object?
So migration schedules are per namespace, right? And I think that's by design because you can customize the way different applications are protected. So yeah, it's not a single object for all namespaces. One name migration schedule for each namespace.
Yeah, I think it would also be contingent on where the storage is coming from. Because, so for example, a lot of the OpenShift things, I'll pick on etcd. Etcd doesn't use PVs for its storage. Well, it does with hosted control planes, but that's a different thing. So, protecting, the OpenShift etcd namespace, even, the pods, the configuration, anything else that's inside of there isn't really going to do you any good, without the data. And we've also talked about, what was it, episode 96, I think? I just looked this up yesterday. Was the one where we tried to do, etcd disaster recovery or disaster recovery by recovering etcd. So yeah, there's a little bit more to it than that. All right.
Awesome.
So I know we're running a little bit over. So I think in the next 5 or 7 minutes or so, if there's any questions from the audience, if there's anything that you all have to ask, please go ahead and send those questions in. And again, for anyone who isn't watching us live, if you think of something after the stream, don't hesitate to reach out. Of course, we love to hear from y'all. And then, Bhavin, please go ahead.
I just wanted to share this with the team. If anybody is attending the AWS Summit in New York end of this month, like in 2 weeks, Red Hat, Portworx, and one of our partners are doing a hands-on workshop where we'll talk about not just disaster recovery, but all the different Portworx features that we discussed earlier in the stream. So things like dynamic volume provisioning, application IO control, autopilot, all of those things you can get a hands-on experience. So it's a free event to attend. Just scan that QR code, register for it. It's at the Pure office, but we are going to use the Red Hat demo platform to spin up sandboxes with Portworx on it for each attendee so that they can follow along and do a hands-on lab in person. But yeah, just wanted to share that with the team since it's coming in 2 weeks.
Yeah, that's awesome. A good one.
Andrew, there was one question that was from earlier in the stream, and it was from Alan, and it was, what is the status of bring your own DNS for OpenShift installs on AWS?
I honestly have no idea. I would guess it's possible with UPI, but I don't know. I'll have to dig around in Jira and see. Or you might, for anybody who doesn't know, a lot of the roadmap stuff is publicly visible for OpenShift. If you just go to issues.redhat.com, you can see all the different OpenShift projects and stuff inside of there. It can be confusing if you're not used to it, because some of the projects have, shall we say, non-obvious names. So here, I'll share my screen real quick because I think that this is an interesting one, or I hope it's an interesting one. So this is issues.redhat.com. Let me make this just a little bit bigger and fill up the screen. So you can see I'm not logged in at all, but I have visibility into all of these different projects that are running inside of here. So I can click on OpenShift Container Platform over here, and it brings up everything that's associated with OpenShift. So what I mean by, various things, like Group A or GRIPA, Group A here, is the team that's responsible for CoreOS and the machine config operator. So if you're not familiar with Jira, when you want to search for issues, you can include this short group name and do things like group A, and then, I don't know, we'll go with unmap. And it'll search just within that particular group for those types of things. So that's one way that you can search for and find things. But they've gotten a lot better about naming these projects, the friendly names here, after things that the world understands, since they started making more and more of this public. But this is a great place where you can go. You can just search inside of here. So if we look for, what was it? AWS custom DNS. So here, allow customer managed DNS solutions for AWS enhancement proposal. So that was easy. So you can see fixed version. So it's targeted at 4.14, release 4.14. I always remind folks that if it's in the future, it's subject to change. That's just the way a roadmap works, right? All those other things, like even if you look down here and you see how it has this hierarchy progress and all these other things, literally until it's out the door, it's always subject to change, in my opinion, in my experience. And for anyone who's curious, CORS, which I don't remember what it stands for, is anything related to the installer. So that's where this one comes in. So yeah, that's apparently they're shooting for 4.14. And I will stop sharing now. But issues.redhat.com is the place to go for all that stuff. I always suggest folks and remind folks that all the roadmap stuff is public. You can go in and you can see all the status of these things.
Yeah, that is new to me, Andrew. Thank you for sharing. Like I attend the roadmap streams that the product management team at Red Hat does, but this is a good page to bookmark.
Yeah, I will not lie and say that, one, I'm not a Jira guru by any stretch of the imagination. And so sometimes tracking through and tracing through, and you'll sometimes see things that come up multiple times. So a new feature will have the epic or the story associated with the feature delivery, and then there'll be tasks associated with that for actually implementing, sometimes over multiple releases, the feature that's coming. And then there'll be additional Jira issues for things like doing documentation updates, doing, training to the support folks, and doing enablement activities. So working with tech marketing folks like me, all this other stuff. So sometimes it can be a little confusing, but it's always a good place to go and look. And of course, reach out to your Red Hat account team. They should be able to point you to specific ones as well. So yeah, excuse me. Thank you, Peter, for the reminder. The OpenShift roadmap presentation comes directly from the product managers. So when those are broadcast, and we do them twice a year now, if you're watching, you can ask questions and we funnel those directly into the product management team. And they're usually really good about getting us answers while the stream is still going. Currently we have OpenShift with Portworx, with ODF, with strange setups. And unfortunately I can't say if someone's better. Yeah. Each one has, strengths, weaknesses, capabilities, all that other stuff. I always take the approach of they're all my favorite children, right? Just like I don't have a favorite child, I don't have a favorite storage thing. It's the one that works best for you in your scenario and all of the qualifications and all the things that you need. Whether that's ODF, whether that's from a partner, whether that's from, whatever it happens to be, Kubernetes native, standalone storage array, everybody's got a different and unique set of requirements. Yeah. Support teams are starting to struggle with all the new tech. I can recognize how that might be happening. I know within Red Hat, we always encourage folks to open support cases, because support cases is how we engage with engineering. If you just reach out to me or you reach out to Jony and say, hey, I'm having this problem, like we'll apply however much knowledge we have and stuff like that. And we might have contacts that we can reach out to, like getting official fixes, official responses, like getting official engagement from engineering to get really deep in-depth stuff basically requires a support case. And gets all those folks involved. When would the UI support be available for disaster recovery to see it all in the console?
I can take that. Like, it's under the works. I know all of everything that we saw today is CLI based. It still is, but we know this is like as the adoption for OpenShift for Kubernetes is increasing, we are getting more of the VMware admins who are used to like a vCenter UI and a SRM UI on board. That's something definitely that we know and we're working on actively.
Yeah, what do we call those? Are they dynamic plugins for the console?
Yeah.
Yeah, they're still a little relatively new. So I know that folks are still catching up.
Portworx actually built a dynamic plugin last month for 4.12 and Portworx Operator 23.5, where you can, right now it's passive monitoring, right? So if you want to get details from the storage perspective, like where are those replicas actually spread out and who's consuming, is it a read write once, read write many, all the different parameters that you configured, you can get everything from the web console instead of trying to be that CLI guru and use different CLI utilities.
Yeah, or having to split across multiple browser tabs, browser windows, all that stuff. Yeah. Everything depends on price. Yeah. What's the three-legged stool? Good, fast, and cheap.
Yeah.
Many thanks to Bhavin. Yes, thank you, Peter, as well as the rest of the Portworx team. So yeah, and thank you, Peter, for the reminder that I'm now 2 minutes past the previous time that I said. Right.
No, thank you, Peter. Like Peter is great. Sorry, Andrew, I'll let you close.
Yeah, no, I agree. Peter is great. I was just on a call before this with Peter where we were talking with various folks, and he was even kind enough to like call out and remind me as he's talking. He's like, "And Andrew, I'm going to ask you this in just a moment," to like remind me to pay attention. And sometimes ADHD gets the better of you. Yeah. So thank you, everyone. We really appreciate our audience for everyone joining. We love the chat. We love to hear from you all. Please don't hesitate to reach out. So email andrew.sullivan, Jony, Jony at redhat.com. Happy to hear from you all. Also, Kubernetes Slack, OpenShift Commons Slack, all of the regular places. We're always happy to hear from you all, especially if you think of something after we go off the stream. We have Bhavin's email address. We're happy to reach out to him as well as the rest of the Portworx team if needed, but I won't ask him to throw himself under the bus, as well as anyone else inside of Red Hat. So don't hesitate to reach out. That being said, Bhavin, really, truly, thank you so much. This has been great. I've learned a lot. I'm coming to realize how much things have changed in the 5 years since I stopped, focusing exclusively on storage in Kubernetes, and it has expanded. So this has been really fun for me. So thank you to you. Thank you to the Portworx team. It's been great.
No, like, thank you so much for having me on, right? Like, this is a great thing that you guys do, 105 episodes in. It's always a learning experience. So not trying to sell anything here, right? Like just trying to show what different capabilities exist in OpenShift or outside with the partner ecosystem and just trying to solve customer challenges. That's it. That's the goal.
Yep. Please don't write me any checks because I don't know what to do with them. I can tell we're over because now my phone has gone off do not disturb and it's now vibrating at me and telling me I'm getting a spam call. All right. So, Jony, I will leave you with any final words, anything that you want to clean up.
Yeah, Bhavin, thanks again. Really appreciate it. It's been awesome working with you the last couple of weeks to get you scheduled. Love to have you back and talk about the other things that you guys got going on. And yeah, just to your point about like not trying to sell anything, it's just a bunch of nerds talking, right? Like that's what it is, right? We're just trying to figure stuff out, like learn new things and new tech. So yeah, I'm glad you came on and it was awesome for me. So I really appreciate it.
Thank you, Jony.
Actually, I won't give you the last word because Babuni asked a question. What is the Red Hat recommendation for backup and restore OADP or PX backup? So I don't know the answer to that, and I will say that because I think that they have different capabilities. What I mean by that is, and Bhavin, you probably know more about this than I do. OADP for a long time was more or less an API for extracting the objects out of OpenShift. It's only been recently that they added in a data mover so that you can actually do something with that. So we always relied on our partners in order to do that. So which one of those you use, I think, is really dependent on the storage solution that you're using, right? Our Hope 9 asked, what's the SLA? So RTO, RPO, right? All play a role in all that stuff. So yeah, Lucas talking about different use cases. So Bhavin, if you have anything to add to that.
No, I think I agree with you, right? Like Portworx backup has been around for a while as well as that backup and restore tool. So we built our own data movers. You can run Portworx backup with Portworx Enterprise as that storage layer, or if you're running ODF and you want to protect those PVs as well, you can use Portworx backup. So we have built that intelligence. Right now, I don't think we're compatible with OADP, but you can still get a full Kubernetes native data protection solution with from Portworx.
Yeah. I definitely don't know an authoritative answer on that one because I haven't used either. If I'm being honest, I don't have anything to back up. Everything I create is temporary and ephemeral.
So again, not doing a plug, but the Portworx backup offers a freemium tier where if you have up to 1 terabyte of application data, you can use the managed control plane, just connect your clusters and start protecting apps without having to buy a license. If you're just trying things out, learning more about how Kubernetes backup works, just go and sign up on central.portworx.com.
Yeah. Which, speaking of which, and thank you for the reminder, I was recently talking with Eric Hendricks over from the RHEL live stream, and he was asking me questions saying that he had flipped his home lab over from RHEL and using virtualization on Red Hat to using OpenShift virtualization. And so he was asking me a bunch of questions and talking about, how to protect virtual machines and all that other stuff. So I don't know, maybe he and I can coordinate some things and bring him on the live stream to talk about from like a hardcore RHEL administrator perspective what it's like to use OpenShift. I think that'd be really awesome.
It would be, different perspective.
Yeah. All right, y'all. Thanks a bunch, and we will see you next week. To our audience, and Bhavin, we'll talk soon.
Yeah, thank you.
They moved the thing. Sorry, I'm struggling to find our little click here for the link for the button because it got rearranged.
Got him.
Yeah. Have a great week, everyone.
See ya.